Hello students, today we're going to be taking a look at section 1.6, compound inequalities. So example 1, understand compound inequalities. How can you use inequalities to describe the sets of numbers graphed below? So on the number line you see here we've got a closed circle at -3 and to the left of which we're seeing kind of graphed, and then an open circle at 2, and then to the right of that you see points graphed, and really solutions we can say, same thing. So the graph shows the solutions of two inequalities. Two inequalities form what we call a compound inequality. A compound inequality is made up of two or more inequalities. Write an inequality to represent the solution shown in each part of the graph. So the first part we'll go ahead and describe, as you can see, with the closed circle graph to the left, something we've seen before. X is less than or equal to -3. And on the right portion of the graph, of course, we've got an open circle at 2 and everything graphed to the right of that, so x is greater than 2. The compound inequality that describes the graph of x less than or equal to -3 or x is greater than 2. So there's two parts to that we have to be mindful of now. Two answers, or two parts of the answer, and as you can see here, the word or. Now, the word or in math, like in everyday life, the word or implies that this is true or that is true. They aren't both true. In other words, it's not an and statement, we say. It's an or statement. So this is true or that is true. And we'll discuss certainly as we go through here the difference between various statements. But in math and in everyday life, the word or implies one or the other. Next problem, you've got a graph here. You've got a closed circle at -4. You've got an open circle at 1. This time you have points or solutions in between, so it's graphed in between. So what do we have? Well, the solutions shown in the graph are greater than or equal to -4. They are also less than 1. So write two inequalities to represent this. So the first of which you see, we have x greater than or equal to -4, because that's true. Greater than or equal to -4, so closed circle graph to the right. And then separate from that, we have x is less than 1 because we have an open circle and everything graphed to the left. The compound inequality that describes the graph is the following. So we have, as you see, we have -4 is less than or equal to x, which comes from this, and x is less than 1. So obviously that comes from that. Together we can write this as follows. So this compound inequality is actually not using the word as we see combining the two, and that would be and. Because here's how you would read this. -4 is less than or equal to x, and x is less than 1. You can combine into one kind of large statement, while here on an or statement you cannot. So and you can combine, while again or you cannot. And you should use the word or when you, of course, put these together, because you can combine them. All right, next, example 2. Solve a compound inequality or. Okay, so speaking of an or compound inequality, solve the compound inequality 5x minus 7 less than 13 or -4x plus 3 is greater than 11, and then graph the solution. Okay. So we're going to go ahead and take a look. It says solve each inequality. The first of which, on the left, it's 5x minus 7 less than 13, and then the other, so or -4x plus 3 greater than 11. So these two on their own will be solved separately. The one on the left, you can start the whole process by adding 7 to both sides. The one on the right, you can subtract 3. So that's going to cancel the 7's here and the 3's there. That leads to 5x is less than 20 on this inequality, and -4x greater than 8 on that inequality. As we proceed, dividing both sides by 5, you see you get 5x over 5, so that's going to divide out to be what? Less than 20 over 5. And we'll do the math in a moment here, though, as we see. We'll need to continue, though, to see on this one, dividing both sides by -4, these are going to divide out. 8 divided by -4, just like 20 divided by 5, easy enough. So x is less than 4, or You don't see the word there, but I'm going to see it here. We're going to see it here in a moment as I scroll down. Or x is less than -2. Graphically speaking, you can kind of see again how the or statement kind of is utilized. So an open circle at 4, graph to the left, or an open circle at -2, graph to the left. Putting them together, the final graph is all points that appear in either solution above. So one or the other. Either or is what we say. And as you can see, putting it together, we know that -2 and also 4, because they're both going to the left. It includes both solutions. So as a kind of neat combination of things, the solution of x less than 4, which is a set of all real numbers less than 4, is your final answer. So -2, because we know -2 is somewhere over here on the graph of x less than 4, and because we already knew that x had to be less than 4 in the first place, it actually overlaps the graph of -2 and then to the left. So down here and down here, the only answer that makes sense here is that x is less than 4. The word or technically wasn't utilized in your final answer. It was utilized in the kind of graphical comparison, but in the final answer, using the graph here, it only ends up being x less than 4. So this is a little bit of a different situation, certainly, than possibly we can relate back to on this particular or statement here. Okay, with this particular or statement here, the graph, back to the original graph, that helps you kind of see how or statements, kind of generically speaking, initially take shape. But this is another example of an or statement that you need to be familiar with, and the graph. Moving on, solving a compound inequality involving and. So what is the solution of -12 less than or equal to 7x plus 9, which is less than 16? Solve each inequality. So this is an and statement. Each one on their own can be solved for x. So here's one side, so to speak. Include the middle here, the middle expression. So -12 is less than or equal to 7x plus 9 and less than 16. So here 7x plus 9 is less than 16. Solve each one. So on this one you can of course subtract 9. Here you can do the same. You'll end up with -21 less than or equal to 7x here, 7x less than 7 there. Divide by 7 on both. You are not dividing by a negative, so you're not having to divide, you're not having to flip the inequality. Here -3 is less than or equal to x, and here x is less than 1. Now remember, this was an and statement. So if we look at the graphs, it's a good start usually. Once you get the inequalities kind of figured out initially. Now you're looking at a graph of x greater than or equal to -3. Now I know it's flipped where -3 is less than or equal to x, but if you actually rewrote it with x on the left side, it would be x is greater than or equal to -3, and that's what the graph here shows. Open our closed circle, pardon, at -3, graph to the right, and then here open circle at 1, graph to the left. Good thing about this question is that you can put the final graph together in such a way where it looks very much like our original example up above where we saw our first and statement. Here's a closed circle at -3, graph to the right. Here's an open circle at 1, graph to the left. The final graph is all points that appear in both solutions, and the word both again implies that, as an and statement should speak to, everything is included here. The final answer, obviously, as it comes together, ends up looking like this. So the solution is x is greater than or equal to -3 and x is less than 1, or you could write it this way. -3 is less than or equal to x and less than 1. That's the more typical way we write our final answer for an and statement. Example 4. Solving problems involving compound inequalities. So Enrique plans a diet for his dog, River. River consumes between 510 and 540 calories per day. If River eats 1.5 servings of dog food each day, how many treats can she have? So this bowl of food is 320 calories per serving, and this bowl is 15 calories per treat. So let's take a look. Model the situation with a compound inequality. We're going to let x represent the number of treats River can have each day. Write an expression to represent River's total daily calories. And you can start to see the process unfold with 1.5 servings at 320 calories per serving. Now remember, 320 calories per serving. The word per implies that you're dividing calories and servings by one another. So calories divided by servings. When you multiply the number of servings times calories per serving, the servings divide out and you end up with just calories. With the kind of blue expression, that was the red one for the first bowl. For the blue, we've got x treats, because we don't know how many treats, but there are 15 calories per treat. So it'll be x times 15 calories per treat, x treats. So that in the end will end up being calories as well, because the treats are going to cancel when you multiply them. So we have 480, because again, that's what we were, or what we can do, excuse me, given what we were told here is 320 calories times 1.5, so there you go, plus, so 480 plus 15x. The 15x expression, obviously we can't do a whole lot with yet, but we will. We're going to write a compound inequality for the number of dog treats each day. So because you need at least 510 calories and at most 540 calories, we're going to set up a compound inequality that is an AND statement. Okay, and I don't disagree, if you don't disagree, that this almost looks like an AND statement, but not quite yet. We are combining two inequalities. So let's put it all together. So 510 less than or equal to 480 plus 15x, again from up above, less than or equal to 540. Continuing on. Hopefully you agree that that's an AND statement, but almost in the sense where we're going to finalize it by solving it. So let's solve it. So there you go, same thing. We're going to subtract 480. So you subtract 480 from the middle expression everywhere you see. On the left side, numbers, and on the right side, the numbers. So this subtracts, and this subtracts as follows. So you've got 30, which is less than or equal to 15x, which is what's left, and that's less than or equal to 60, because that's that particular math. As you continue on, divide 15 from everything, because 15 is in the middle term. It's that coefficient we say. So divide 15, do it here, and do it there. Whatever you do to one side of an inequality or an equation, you've got to do to the other sides, or sides. In this case, there's more than one side. It's more than two sides. All right, we continue. This, of course, divides to be 2. This, of course, divides to be 4. So 2 is less than or equal to x, which is less than or equal to 4. That is the solution. Now let's interpret it. So River can have at least 2 and at most 4 treats each day. This does conclude our notes for today. Like usual, if you have time to maybe go through and look at the try it questions, those are excellent follow-ups.